Okay, so that's on. I've got the chat up. Okay. All right, so we're at 15. So we'll go ahead and get started. You guys, today is actually not going to be that long of a lesson. We'll learn one thing that's new, but we're going to review the IROC. Again, we're going to do another problem like that. We are just going to do one problem. These take a little time though. I want to make sure you guys are clear on how to use the formula. I want to make sure you're clear on the algebra because that's going to make or break you in this kind of problem. And then we're going to take it one step further. So let's get started. I'm going to put a function on the board, and I'm going to have us calculate the instantaneous rate of change at a certain point. Okay, so our function is going to be f of x equals 3x squared minus 4x plus 2. So I give you the function. Remember, I could ask it in two different ways. I could say, find the instantaneous rate of change at a certain point, or I might say, find the slope of the tangent line at a certain point. But you guys, no matter which way I ask it, I still use the IROC formula. So I want to find the instantaneous rate of change, or slope of tangent line, at, and remember here, I could put at a equals a number or at x equals a number. Either one I know is indicating this value will go in for a. So at a equals 1 or x equals 1. Either way, I know the value is a, whether it says a or x in the original problem. And I keep saying both of them because problems are all different. So sometimes it will say a equals 1, or it will say x equals 1, to make sure that you know 1 is the number we're going to use. Okay, so let's start by remembering what this formula looks like. Remember, it is a limit calculation. So it's going to equal the limit as h approaches 0 of this ratio here. So on top, we have f of a plus h, and we have minus f of a, and on the bottom, it's just h. So in order to use this formula, we have to find two things. First of all, we need to find f of a plus h, and then we need to find f of a. That way I can stick those values up here, and then I can continue working the problem. So the first thing I want to do is let's go ahead and sub in that 1 for a, so we know what we're looking for. So this is the limit as h approaches 0 of f of 1 plus h minus f of 1 over h. So that was a pretty simple step, right? All I did there was I replaced a with this 1, and remember, that's given in your problem. Okay, so it looks like my next step needs to be finding f of 1 plus h and finding f of 1, so I can stick those in there. So let's do that. And guys, as I find these, now working through this formula, you know, we go from this step to this step. Our next step in this formula, in the limit formula, will be plugging in these values. But finding the values is side work. So, and I want to make sure you know that that is, it's work on the side. It's not actually continuing to work this, this particular formula. I just need those values so I can continue. So I'm going to erase all but this last line. Okay, so this is where I'm at in my limit calculation. And I'm stopped here while I take my work to the side and find f of 1 plus h. Okay, so f of 1 plus h. Remember your function, it was 3x squared, so it's going to be 3 times 1 plus h squared minus 4x, so minus 4 times 1 plus h, and then we had plus 2. All right, so like I said in the beginning, the algebra is what's going to get you. It's not remembering this formula or knowing the steps. It's this right here. First of all, every time I subbed in the 1 plus h, I made sure it was in parentheses because both the whole 1 plus h needs to be squared. And the whole 1 plus h has to be multiplied by this 4. Now with this 3, be really careful. I cannot distribute this 3 out to this 1 plus h until I square the 1 plus h. So that's an order of operations things, right? I have to square first, and then after this is squared out, then I can distribute that 3 to the terms. So we're gonna leave the 3 alone. Let's go ahead and remember what we're looking for here. So 1 plus h squared is 1 plus h times 1 plus h. I have to FOIL this. Now here, I can absolutely go ahead and distribute this 4 to both of these terms. And notice I am going to be distributing the minus 2. So I'm going to have minus 4 and then minus 4h. And then I have that plus 2. So let's FOIL this out. Again, I still am not going to touch this 3. I'm not going to send it over to these terms until I FOIL it out. So let's FOIL, guys. 1 times 1 is 1. H times 1 is h. H times 1 is h again. H times h is h squared. So I FOILed that out. Over here, you might as well do the minus 4 and the plus 2. Let's go ahead and put those together. So I will have the minus 4h, but my constant, combining these together, I'll have minus 2. So I'm here. Now, as you do these problems, if you want to, you could combine these h's together and distribute the 3 at the same time. You can do more steps than one, on a line, but I am going to take it small step by small step. So the next thing I'm going to do is combine those 2 h's together and call them 2h. Then I have plus h squared. Then I have out here minus 4h minus 2. One thing I want you to make sure you remember is you can't lose these parentheses until you actually distribute the 3. If you lose them, then this 3 is only going to touch this 1 and you're not going to get it everywhere. And make sure they stop here too. This 3 doesn't distribute to everything in the problem. It just distributes to this term right here. So it's that stuff that seems really particular or kind of nitpicky, if you will, but it's the stuff that's going to cause mistakes if you don't write it in this particular way. So let's distribute this 3 now. So 3 times 1 is 3. We're going to have plus 6h. We're going to have plus 3h squared minus 4h minus 2. Now all we have to do is combine like terms. So let's see what we have. We have 3h squared, and just one of those terms. I'm going to put that in the front. So I have 3h squared. I have plus 6h and minus 4h, so that will leave us with plus 2h. And then here I have 3 minus 2, so that'll leave us with a plus 1. So you guys, this is f of 1 plus h. I'm going to, in my formula, in the next step, I'm going to replace where it says this, and I'm going to put this there instead. But I needed one other thing. Before I can continue with the formula, with the limit, I have to find f of a, right? So just f of 1. And that's a really simple calculation, but it's still side work that I have to do. So I found f of 1 plus h. Let's now find f of 1. So it's going to be 3 times 1 squared minus 4 times 1 plus 2. So I get 3 minus 4 plus 2, and what we end up there is just a 1. So f of 1 equals 1. So we have both things we need. Well, you guys can help me remember this so I can put it in. I'm going to erase it, but just help me remember 3h squared plus 2h plus 1. I probably will. It's not going to take me long to write it, but, and remember that f of 1 is 1. So where were we in our formula? We were at the limit as h approaches 0, and I'm going to go ahead and rewrite this again. Thank you. That works. You just chat it out for me. This is where we were. Now I can plug in those values. So I have the limit as h approaches 0 of 3h squared plus 2h plus 1. It was plus 2. Yeah. And then minus f of 1, and that was just 1. So now I'm here, and that's all over h. You guys, this is that step right here is a good checkpoint to make sure that you get things right.
I was being an idiot and accidentally kicked Dalen's wall and there's a hole in it now.
Oh yeah, I saw.
Yeah.
I came over.
Make sure you mute yourself if not. So from here, this is a good checkpoint because at this point where you have f of 1 plus h minus f of 1, anything that does not have an h in it at this point should cancel out.
And he found my pen. It was in the
1
dryer.
minus 1.
The small one.
Yeah.
It broke. But, I mean, this still works. I just put on a different one that sucks. And I...
Okay, so this 1 minus 1, these are the only two terms up here that don't have an h in them. So it makes sense that they would cancel each other out. And they have to. Guys, if you go to this next line and you have a constant running around, you're not going to be able to complete the problem. So make sure that that happens. Let's look at what our next line looks like. We have 3h squared plus 2h over h. Now, why was it important that all of my terms at this point have an h term? Well, it's so I can divide an h out of everything, right? That way I get rid of my denominator and then I can actually take the limit. I can't take it with this h on the bottom because you put a 0 right in there and your problem's undefined all of a sudden. So we are going to take an h out of everything. So divide a factor of h out of this h squared will just become an h to the first. And let's see what we have left. I have 3h plus 2. So that's all that's left once you take an h out of all three terms there. Make sure that this is in parentheses now. So fraction was grouping it together on, that's what a fraction does. It's a grouping symbol. But now that we don't have the fraction, these aren't grouped together automatically, so you do need the parentheses. I know that as you're working a problem, you know that you're taking the limit of this whole thing. But if you don't have the parentheses, then nobody else knows. Like as I'm reading your work, that's not what it shows me. So put the parentheses, just, practice proper notation. Now we can take the limit, right? I can take this h as it approaches 0 and basically put a 0 in here for this h, and that is the act of taking the limit. So doing that, if I put a 0 in here, this whole term is just going to go away. It's going to become 0, and I'm going to get an answer. You guys, I'm going to get this. So this 2 is my answer. Remember what that 2 represents. It is the slope of the tangent line to this function at the point where x equals 1 or a equals 1. So let's draw that out a little bit. So let's say this is that function. Let's say the point where x equals 1 occurs right here. And I don't have this in the plane, but if it was in the plane, let's say this is the line where x equals 1. What I found was I created a tangent line. Remember, that's a straight line that touches the function in this one spot where x equals 1. What I found is the slope of this line. So the slope of this line, or m, you know, we use m for slope, equals 2. Okay, so that's what we found. Implications of that. It just means that at this point on my function, just for that instantaneous moment where x equals 1, that is the direction, the exact direction that the function is moving. Because this function is not a straight line, if I even move off of this point just a little bit, that slope is not going to be accurate anymore. Because as you move along the function, the direction it's going changes even just slightly as you move from point to point. But for that point, that's exactly what's happening. And it is 100% accurate. So that's what we found, but I want to take it one step further. I found the slope of a line. Usually when we're talking about lines, if we find the slope of a line, we might want to go one step further and find the whole equation for that line. So this line here, I know it has a slope of +2, but I think I could find the equation for that entire line. And I actually have enough information already, and I'll show you where to find it. So let's take a trip back to algebra, writing equations for lines. You get some information from a problem, and it says write an equation for this line. Well, you guys, your go-to form, you have a template for that equation, right? Now, there's a lot of different forms of a line, but the one that we use mostly, and the one that you probably remember the best, is the slope-intercept form. The y equals mx plus b. Now, I just found m, so that's a good start. What I don't have is b. Remember, and if you don't remember, that's okay. Recall that b is where the line crosses the y-axis. So it's the y-coordinate of the y-intercept. So if I don't have the y-intercept for this line, I don't have b. But if I don't have b, I can't write the equation for the line. It's a problem, right? Well, think back to those problems. If you don't have the y-intercept, the next best piece of information that you could use to write this line equation is just any other point on the line. So y-intercept is the best because I could just stick it in there for b. But if you have any other point on your line, you can actually use this to solve for b. And that's what we're going to do. The question is, do I have another point on my line? Well, I do, right? It's right here. I already said that this line is touching the function at this point, which means that this point, remember this was x equals 1, is a point that lies on my tangent line. Do I already know the y value at that point is a question. Didn't I already find that in my IROC calculation? So you guys, I found, so x equals 1 here, that's the x value. To find the y value there, you would just do f of 1. We did that, and we got 1, right? So you guys, finding the equation to this line, we actually already found all the information we needed to do that. So it's just taking that information and taking it one step further. So we found f of 1, which is it's the y value of this point on the function. Remember, that point on the function is the exact same as the point on the line. So don't let that confuse you and say, oh, well, we need a point on the line, but what we found was a point on the function. They are one and the same, because that's how a tangent line works, right? That's the point that they share. So because I know they share this point, I know that this point is on the line. This point being x equals 1, y equals 1. So now I have a point on the line. I already already have m, which is the slope. Remember, I still don't have b. This doesn't mean that b is 1. It means that I can solve for b. So I know m is 2, and I know a point on the line is 1, 1. So what am I going to do with this? Well, first of all, I'm going to put the m in there since I already know that. And now I have y equals 2x plus b. I still don't know b, but let's use this xy point. Let's plug it in for this x and y for a minute. What that's going to do, it's going to leave b as the only unknown in the equation, which means we can solve for it. So x is 1, y is 1. Put those here. So y equals 2 times x plus b, and solve for b. So I have 1 equals 2 plus b. Let's subtract 2 from both sides to get b alone. And I get -1 equals b. I have b now, and I already had m. So now make sure you know that this isn't where we stop. This isn't your answer. Remember, your answer is the whole equation for this line. So the equation y equals mx plus b. Now that I know both m and b, the equation for this particular tangent line is going to be y equals 2x minus 1. So I put the b in right there, and then I already knew the m. And that's hard to see because I put it in the glare spot. Y equals 2x minus 1. This is my equation for the tangent line.
Someone has a question in the chat.
How did I get the x equals 1? X equals 1. Oh, so the x equals 1, remember that was in my given problem where I was looking for the IROC at x equals 1. So that's where this point came from. This point on my function that I was calculating the IROC for was x equals 1. And from that, remember I put that x equals 1 into my function to find the y value there, and it also happened to be 1. So that's given. So guys, if I gave you a problem and I said find the slope of the tangent line, or even the equation of the tangent line, you know, all the way down to the end, and I said at x equals 3, then when you did your instantaneous rate of change calculation, what you would find is a point on the line where x was 3, and then you would have this y value, f of 3. But in our case, because I was given the 1, that's the point I found. If I was given a 3, the point that I would be using here would be 3 something. So it all depends on what's given in the problem. So we do not often have to write the whole equation for a tangent line. There are a couple of times though, so I want to make sure that you can take information that you already have, because like I said, if you calculated the IROC already, you already have the slope because that's the answer to that equation. And you already have this point because you had to find this point to put in to f of a, remember? So you had to find this to put into this, and the answer to this was your slope. So you already have all the information needed to find this equation. You just have to know how to take it from, you know, from one place to here. And if you can remember this, that should get you there. Let's see. I don't know if any of you guys have started your IROC homework. You know, if you do have any questions like about any of those problems, we can go over those. I don't think I gave you anything crazy. I think they were pretty easy. Some of the functions I gave you were probably even easier than this one. But other than that, so I could move on here, but the next section is one that I really like to do in person. So that's why I'm gonna save that for Friday, and we can do that in class together.
I have a question.
Excuse me. Can you go over one of the problems
on homework.
Sure.
Ask that same thing. Okay, so I was doing the 1/x-2 problem, and the
Okay.
-1 and 1, and I literally have done this problem 5 different times, and I keep getting the same answer, but on MATLAB it tells me it's wrong. And I do the help solve this problem thing and go through the steps bit by bit, and all my steps are right, but it keeps saying my answer is wrong.
Okay,
So,
can you read off the problem to me? So is this an IROC problem or something different?
it was an AR, the average rate of change one.
Oh, okay. So you were looking for average rate of change. And your function is what?
1/x-2.
1/x-2. And then what are your bounds, A and B?
-1 and 1.
Okay, one more time.
-1 is,
Negative.
and 1 is the B.
Okay, so -1 and +1.
Yes.
Okay, cool. So you're going from -1 to +1, average rate of change. So let's start by finding f of -1. And if I end up getting the same thing you did, then what I would really want you to do is like where it says it's wrong, and then I can.
Okay.
Dang, did her screen freeze for you guys too? Oh, here we go.
Yeah.
Yeah.
I think she's back now. Yeah, she's back now.
So confused.
Okay, can you hear me?
Yeah, there we go.
Okay, I don't know what happened. Zoom just closed out totally, and then it came back on its own. So that was special. All right, so let me get back to this problem. So what I've done here is I found f of 1, and I got -1 as that answer. And then f of -1, I got -1/3. Is that what you got?
I got those same answers, yes.
Okay, cool. So now let's go to your average rate of change calculation. So this one's a little more difficult because it's got a fraction in it, but the average rate of change. So on top is going to be the difference in the outputs. So it would be -1 minus -1/3. So because this was f of 1 and this was f of -1. And then on the bottom, you would have 1 minus -1. So let's see, the bottom's real easy because it's going to be a 2. The top, we need to work this. So first of all, these two minus here, it's going to be a plus. So what's 1 plus 1/3? Isn't that, so let's take it over here. So -1, couldn't I write that as -3/3? So I can put it with this one, and it is going to be a plus. So this is can be written as -3/3 plus 1/3. So you have -3 and you want to add 1, so it gives me -2/3, and that's on the top of the fraction, right? So this is what I have. Now, obviously, I can't leave my answer like this, right? So, because we've got a fraction inside a fraction. But if I think about this as being a 2/1 at the bottom, I can flip and multiply, you know, do fraction division. So another way to write this would be -2/3 multiplied by 1/2. And what I'm going to end up with is -2/6, or -1/3. So this is what I get. Is that what you got also?
Okay, that's what my math went wrong right there.
Right there. So was it maybe here that got you?
That's where I messed it up right there. Yeah.
Okay, so yeah, and this one, honestly, if it had been a fraction on the bottom already, it would have been more clear to flip and multiply, but you can always make this into a fraction. Another way to think about it, if you don't want to do the flip and multiply, I don't want to be more confusing or anything, but anytime you have a fraction and you're just dividing by a whole number, another way to do that is to just put this whole number on the bottom with it. Notice that's what happened. It's like, when you divide by 2, it's like cutting in half, right? So if you have a third, but you want to cut that in half, what do you end up with? You end up with a 1/6. So it's like we put these two together on the bottom. But again, I don't want to be confusing about that. That's kind of a shortcut way, but you can always turn this into a fraction and then flip and multiply.